Hello everyone, welcome to the continuation tutorial of DITFFT algorithm. So far we have been able to develop up till this stage where we have decimated the given discrete time sequence into its two components of even and odd sequences. So F1 and f1 of k and f1 of k plus n by 4 is developed in this manner. Now moving further, here we see that the value of k or the range of k starting from 0 it goes up till n by 4 minus 1, and n being 8 by 4 is 2 minus 1 is 1, so that means k will hold only two values 0 and 1. So when I substitute k 0 and 1 in these two equations, I'll get various samples of the sequence f1. But before I substitute the values for k, I'll write the similar equations for our other sequence, which is f2. So I'll not derive the whole thing again, but it will be similar to the sequence f1 of k. So the other sequence f2 will be defined in the similar manner as f2 of k will be equal to g21 of k plus wn by 2 k into g22 of k, and similarly f2 of k plus n by 4 becomes equal to g21 of k minus wn by 2k into g22 of k. And for both of these equation, the k ranges from 0, 1, 2 till n by 4 minus 1. Now when we substitute the value of k in all the four equations corresponding to f1 and f2, will have the specific sample values. Now when I substitute k equal to 0 and 1 in this equation, now in this equation when I substitute k equal to 0, I get the first sample of the sequence f1, which is f1 of 0, and when I substitute k equal to 1, I'll get f1 of 1. Because f1 is a sequence which is having length 4, that means it should have 4 different sample values at f1 of 0, f1 of 1, f1 of 2 and f1 of 3. Now the first two sample values are obtained from this equation by putting k equal to 0 and 1, and the next two sample values, that is f of 2 and f of 3, we shall obtain from this equation by again putting k equal to 0 and 1. So on substituting the values, I get f1 of 0 to be equal to g11 of 0 plus wn by 2 0 into g12 of 0, and when I put k equal to 1, I get f1 of 1 equal to g11 of 1 plus wn by 2 1 into g12 of 1. I need the specific sample values in order to develop the diagram for the diagrammatic representation for the sequence. And similarly for these two equations, when I substitute k equal to 0 and 1 in this equation, I'll get different values. And but yes, before that I'll find all the 4 sample values of f1. So f1 of 2 will be equal to g11 of 0 minus wn by 2 0 into g12 of 0, and similarly f1 of 3 will be equal to g11 of 1 minus wn by 2 1 into g12 of 1. So these are the 4 specific sample values of the sequence f1 of k, and similarly we can find the 4 sample values corresponding to sequence f2, which I'll just write down here. So f2 of 0 will be equal to g21 of 0 plus wn by 2 0 into g22 of 0. Next, f2 of 1 will be equal to g21 of 1 minus wn by 2 1 into g22 of 1. Quickly I'll write down the next 2 values. f2 of 2 will be g21 of 0 minus wn by 2 0 into g22 of 0, and the fourth and the last sample value of the sequence f2 of k, which is f2 of 3, becomes equal to g21 of 1 minus wn by 2 1 into g22 of 1. So this gives me the sequence f2 of k in terms of g11, g12, g21 and g22, which is the decimated length 2 sequence which we have developed out of f1 and f2. So now it becomes easier to realize these set of equations in the diagrammatic representation, which will depict the different stages of decimation. Now in this case, when we combine the first stage of decimation with the second stage of decimation, and finally the third stage is where we get the Fourier transformed sequence x of k, the combined stages will look something like this. Now this is the combination of all the stages of this algorithm. Now you can very well relate this diagram with the equations which we have developed. So this was the stage 1, where the sequence x of n was decimated into 2 sequences of length n by 2 each. One sequence was f1 and the other sequence was f2, and please notice that we are working for n equal to 8. So when n is equal to 8, we have 8 samples to start with, and we'll go on decimating the sequence until I have a small sequence of length 2. So here the sequence x of n is decimated, and we've been able to decimate it into 2 sequences of length 4 each. The first sequence is named as f1, having 4 samples 0 to 3, and the second sequence is denoted by f2, having again 4 samples 0 to 3. Now the next task is to take this to further stage of decimation, where the sequence f1 is again broken down to its even and odd samples, and we name it by g11 and g12, and similarly f2 is further decimated to its even and odd samples, named respectively as g21 and g22. Now you can also, instead of these blocks, you can also depict the stage 3 as I have depicted by these kind of arrangements, and this is also known as the butterfly structure, because I don't know, somehow it resembles a butterfly, that is why it's been named after it. So this is also known as the butterfly structure, where we show how the different sequences are merging with each other, or interacting with each other to form the given sequence. So you can look at this sequence in this direction, left to right, when you want to see how the discrete Fourier transform sequence is obtained, and you can try looking at this diagram from right to left when you want to learn how the resultant sequence is obtained from the different combinations of the previous small sequences. So this completes the DITFFT algorithm here, and I hope this long derivation or long algorithm was understood by you all nicely, and I'll try to solve one numerical based on this DITFFT algorithm, which is very important when you are attempting a subjective type of examination for DSP. So I hope this tutorial was of help, and keep supporting the channel, keep sharing, and keep visiting the channel as much as you can. That's a great support, and I wish you a good time ahead, and see you soon. Bye.